Hello everyone, this is Sean with Alexander Tutoring, and today I'm going to do a video for all my geometry students on sines, cosines, and tangent functions. You probably recall seeing this in class as the acronym SOHCAHTOA, and that's all it is an acronym to help you remember 3 different equations you'll be using a lot in this class. So this is a topic that's not going anywhere. If you take pre-calculus next year, it's going to be all over the place. If you take calculus after that, it's going to be even more all over the place, and if you continue with math after that, they're just not going anywhere. So you first see them in geometry, so I really wanted to make sure that you understand it really well right now. Okay, so SOHCAHTOA is simply an acronym to help you remember 3 different equations. So I broke it up for you here. You can see the first part, the SOH. That's to help you remember the sine of theta equals the opposite side of a right triangle divided by the hypotenuse. The CAH, is to help you remember that the cosine of theta is equal to the adjacent side of the triangle divided by the hypotenuse. And finally, the last one, TOA, is the tangent of theta equals the opposite side over the adjacent side of a triangle, a right triangle specifically. This only applies to right triangles or a triangle with one 90-degree angle. So let's see what all those words mean. The opposite, adjacent, hypotenuse, what am I talking about? Well, I drew this picture of a triangle for you over here. And those are all relative to the angle in question. They're always going to give you an angle on a problem like this. So here I use the Greek letter theta, but opposite means the side of the triangle directly opposite that angle. Okay, so if you go straight across to the opposite side of the triangle, that side of the triangle is what we're going to call the opposite side. Adjacent means next to, basically. So you can see here that this side of the triangle is kind of next to the angle. So we're going to call that the adjacent side. Again, the important part is it's all relative to the angle in question. And then finally, hypotenuse, well, that's a big fancy Greek word, but just know that it means the longest side of a right triangle. Okay, so now that you get that, let's look at a typical problem that you'll see in your geometry class. And usually what they'll do is they'll give you a right triangle. I'll draw one here. And they'll give you an angle in one side of the triangle and basically ask you to find another side. So let's say I'll give you the hypotenuse. Let's call it 12 centimeters. Okay, and then they want you to find the x, or the side of the triangle over here. Well, let's first determine what side is this that x is on. Well, as you recall from the other picture there, it's all relative to the angle, right? So if we go straight across, we land on the opposite side of the triangle from that angle. So this x here, that's the opposite side. Of course, this would be the adjacent side because it's touching the angle. And then the 12 centimeters that they gave us, that's the long side. That's your hypotenuse. Okay, so the big question is, which of the 3 equations above are we going to use to solve for x, or the opposite side in this case? So that's a problem that students sometimes get stuck on. Which equation do you choose? And there's a really easy trick for it. There's always going to be a side that you know and a side that you want to know. And so what you want to do is pick the equation of the 3 over here that has both the side that you're given and the side that you're asked to find. So in this particular case, we were given the hypotenuse over here, right, 12 centimeters, and x, the side we're trying to find, is the opposite side. So we want to pick the equation of the 3 that has both the hypotenuse, the side that we know, and the opposite side, the side that we're trying to find. So you can see that the first one is right because the sine of theta goes opposite over hypotenuse. Opposite is what we want to find. Hypotenuse is what we know. We're going to use that guy. So I'm going to write that down here. So we're going to go sine of the angle, which in this case is 60 degrees, equals opposite, which in this case is x, that's the side we're trying to find, divided by the hypotenuse, in this case 12 centimeters. Okay, one thing I see a lot that I just wanted to point out, if you look over here, sine of 60, that does not mean sine times 60. You used to maybe sound like 3x, that means 3 times x. But this is f of x notation, okay? This is like this means the sine of 60 degrees, or you're plugging 60 into the sine function. So really this is like f of x notation. And really all this is like, okay, well, what function is it? Well, we're just going to replace the f with sine to let you know that it's a sine function. and then 60 is getting plugged into the sine function. So 60 is going in, some number's coming out. Which number comes out? Well, you can use your calculator for that. Okay, in fact, let's do that right now. So if you plug sine of 60 degrees into your calculator, the first thing you need to make sure of, probably the most common mistake of all time right here, is that your calculator is in degree mode, not radian mode. There's two ways of measuring angle. Well, there's a lot of ways, but the two ways you're going to see in this class are radians. And in this problem, I use degrees. So your sine, cosine, tangent function on the calculator will give you the wrong answer if you're in radian mode. And they usually default to radian mode. So just go into the settings, and it usually says mode if you use like a TI, and make sure it's set to degrees, okay? So if you do that, and then you plug in, you do sine of 60 in degree mode, you're going to get a long number, but it's roughly 0.866 rounded, okay? Equals x over 12 centimeters. Now this is just a regular algebra equation. We want to solve for x. We can see x is being divided by 12 centimeters, so all we got to do is multiply both sides by 12 centimeters. 12 centimeters, like that. Cancel, cancel. So we have the x by itself. And now you can simply use your calculator to do 12 centimeters times 0.86, which I will do myself, because I can't do it in my head, to get roughly, I'm going to round here, 10.4 centimeters. Okay, does that make sense? Let's go back to our triangle. So we just found out over here that we think that x equals 10.4 centimeters. Well, I like that number because it's less than 12. We know the hypotenuse is the longest side, so it's good that it's less than that. So this seems like a good answer. So that's what I really wanted you guys to understand. The main tricky thing I see people get tripped up on is which equation do I use. Again, the big trick is they're always going to give you one side of the triangle, and then they're going to ask you to find another side. So just find which of the three SOHCAHTOA equations has both the side that you know. In this case, we knew the hypotenuse, which was 12, and the side that they're asking you to find. In this case, we want to find the opposite side. The one that had both was sine theta. The problems will flip that around on you. One problem, they'll give you the opposite side, ask you to find the hypotenuse, but they can't trick you because you know the trick. You just find the one that has them both. Like if they gave you, I'll just really quickly before I sign off, just to give you, see how they can change it up on you. If they gave you another one that was like, okay, well now I'm going to give you this side, and actually, you know what I'm going to do? I'm going to, and let's say what they gave you. I'm going to be tricky here. What if they gave you this angle? Oops. What if they gave you this angle here and said it was 30 degrees? This will help me show you. And then they found this one, and they said, okay, well, what's the value of this side? Now, here's the tricky point. Which side's the opposite and which side's the adjacent? Now, well, it's all relative to the angle in question. Okay, so it's always, we can see they gave us a 30-degree angle. Guess what? This is now the opposite side because it's opposite the angle they gave us. This is the opposite side. This side is now the adjacent side because it's next to the angle they gave us. And hypotenuse is always the long side. So that's kind of a tricky point there. You can see over in the old problem here, they gave you that angle, so the opposite side was over here because that was opposite the angle. But on this one, I'm giving you a different angle, but again, it's always opposite the angle, so you always go straight across. So now this is the opposite side. This is the adjacent side. Okay, so in this one, x is the opposite side. That's what they want us to find. They gave us 10 is the adjacent side. I should put a unit in there. We'll call it centimeters again. So again, which equation do we want to use? We want the one that has the side they gave us and the side that they want us to find. So in this case, we know they gave us the adjacent side, and they're asking us to find the opposite side. Which one has both? The answer is tangent has both opposite and adjacent. So we would then say that the tangent of 30 degrees equals opposite, in this case x, over adjacent, in this case 10 centimeters. You can see this looks familiar. Just like before, in fact, I'm going to leave this as an exercise for you to solve. You can put the tangent, 30 degrees into the tangent function, multiply both sides by 10 centimeters. I'll let you all finish this one off. But I just wanted you to see a couple permutations of this. And then there you go. Okay, I really hope this was helpful. I'm going to make a follow-up video on this one next time. Again, I really hope to help. If you have any questions, don't hesitate to reach out. Thanks so much. Have a great one. Bye.